Hey, what's up, guys? Welcome back. Little bit of kind of an announcement, I guess. Oh, jeez. Um, little down. I got offered this job out in Boston. It's a pretty cool opportunity, like being out in Boston. I honestly didn't really expect that I was gonna get it. I thought, I felt like I could have answered the interview questions much better. I mean, I had like 3 rounds of interviews, so the last one, with the manager, I just felt like I could have done much better. I guess I got really nervous. I was, it's whatever, but I guess it just comes after more practice. But anyway, the following day, I got a call from the recruiter and told me that I had the job, which was pretty crazy because I don't know. There was like 6,000 applicants. So, obviously I thought I had probably absolutely no chance. But I got the job. And it was kind of frustrating because they were looking for someone for 9 weeks, but I could only do 8 because of all my visa restrictions. So, it is what it is, but, I guess I don't know what you can do. I guess I just got to keep going, keep grinding. I guess it's a little bit of like a setback, but it would have been a really cool opportunity to actually be out there, for the summer beyond Boston. I've never been, so it would have been cool to learn from all those talented people there, and it doesn't work out. So maybe it's for the best. I don't know. But either way, if I had that job or not, I wasn't going to stop what I was doing here. I feel like, I've shown a lot of progress, and I want to keep doing that, so, yeah, we're going to keep going with Leetcode. I've kind of started this full stack camp sort of thing, boot camp thing. So I'm excited about doing that too. And mainly I kind of want to learn about how to integrate front ends and back ends, and with APIs and things like that. I feel like that's something that I have not the best knowledge about, but so I'm excited to learn about that. And yeah, so just thought I'd have a little bit of an announcement for people that click on this video. But yeah, I'm going to keep going. So I feel like you have one setback, but you just got to keep grinding. And, I'm going to be looking for a full-time job in December, so might as well keep rolling with it. So, but yeah, appreciate you guys sticking around. If you do click on this video, I appreciate your support and everything. So anyway, let's get into our Pokemon sound of the day. So we got, I think, was it 62? No, that was yesterday. We got 63. We got an Abra. It's be an interesting sound. I don't even know how to do it. I don't even know how. I could never do any of these sounds, to be honest. And I'm actually quite tired too. I was up pretty late, so it is what it is. So, yeah, that's our sound of the day. Yeah, our announcement of the day. Let's get into some problems. Count number of colored cells. This looks like yeah. Infinitely large two-dimensional grid of uncolored unit cells. You are given a puzzle measure n, indicating that you must do the following routine for n minutes. Oh, okay. You must do the following routine for n minutes. At the first minute, color any arbitrary unit blue. Every minute thereafter, color every uncolored cell that touches a blue cell. This is some sort of a math problem, I feel like. Yeah. So think about some sort of formula. Well, we got 1, 4. What would 3 be? 9. Man. Let's see what it would be. We'd start with 1, we go to 4, and we go to 9, 10, 11, 12, 13. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 plus 12. Bro, I don't even know what this is called, to be honest. I don't even know the formula to do this, bro. Wow. I does not equal n. What's the little formula, bro? Like, I don't know. What would be formula to count? Let's return our res, right? We do, well, here's the formula. Res is equal to 2n. Res is equal to 2 times wow. An object is not callable. What? What? cur is equal to this, and we do plus equal cur. There's something wrong with this formula. Oh, it looks like a function call. Oh, geez. That's why. Okay. We need times here. Two times n. Maybe there's no plus one. Two times n minus 1 plus 1. Bro, what is wrong, bro? Well, we're not iterating. Oh, each layer adds. We don't need the formula. We can just do, well, guess we can start from 1 because there's no 0 layer, right? I mean, well, I is less than n, then we can just do, well, cur is equal to 4 times I, then go and return rest. That's an infinite loop, dude. How do we get out of the infinite loop? Oh, we need an increment. Let's equal to 1. There we go. Okay. What's the fastest way, bro? Just return. I kind of wish I got that faster, dude. Like, I mean, bro, technically it is, yeah, 4 times the. Times 1 is 4. 4 times 2 is 8. Okay. Now we're on a little. Alright, well, we're gonna keep going. And I get distracted. Oh, dude, my eyes, bro. Oh, alright. Let's take a look. Take a look. Study plan. Oh my gosh, dude, it's black now. That's so much better. I wonder why that changed. Video. I want to keep powering through these binary search trees, bro. Minimum absolute difference. BST. Let's check it out. Given the root of binary BST, return the minimum absolute difference between the values of any two different nodes in the tree. Return the minimum absolute difference between values of any two different nodes in the tree. I assume this is sort of backtracking or something. First search binary tree, that first search tree. Given the root of it's the difference between. So I assume here the output is 1 because you have 2 minus 1. Here the output is 1 because you have 1 and 0. I'm trying to think how you go about solving this problem. Four two one 426 131. Six minus 2. I think we started this node. Okay, so obviously here we're gonna need some sort of reds, right? To return. I'm gonna get a hint here. Leetcode 530 minimum absolute difference in BST. So they're saying an in-order traversal. Left root right. Okay. Left root right. Remember we did in-order traversal only a few weeks ago, but I'm not really 100% sure kind of how to implement that. If it's left root right, I think how can we do this? Like this was the tough one to implement because I'm not really, man, I'm not really too sure. From leftmost node. But how would you go boom, boom, boom? I don't know. A current or stack? I mean, technically to solve this problem, we could just traverse the tree, add all the values, make a list, and then sort it, and then find the minimum. You know, we could do that, but again, I just feel like that's cheating. You know, like I feel like you're not really like doing the problem properly, to be honest. So I'm kind of looking at the past problem that we did on February 14th. I'm trying to understand how we can implement this. Create a stack. Our current is equal to a loop val while current or stack while current because we're kind of reversing. Like open current. Current is equal to current dot left. Well, I guess we want to pop from our stack, so stack dot pop, right? Because we're gonna add all the values here. When it's not equal to, when it's equal to null, then we're gonna pop all the way back. And we're gonna pop all the way back to our root node, and then we're gonna want to do stack.append. There's no attribute left. We need to somehow talk about if it's null. What if it's null? Okay. 1, 2, 3, 4, 6. Okay. Sorted array. Then we have a then we return, well, the min between sorted array 0 and sorted array 1. edge case here. So return min sorted array 1 if sorted array 0 is less than sorted array 1, else sorted array 1 minus sorted array 0. Return the min if sorted. Okay, we return if sorted array 0. I guess they're both. Oh man, how do we do this edge case? Like, we can have negatives too, right? No, we can't have negatives. Man, I have to go to the bathroom so bad. Maybe we gotta do, well, if sorted array 0 is equal to 0, then return sorted array 1 minus sorted array 0. Okay, let's see if this returns. There's probably gonna be some other edge cases for sure. Like, oh, okay. 547 expected 1, but we returned 4. How is the output meant to be 4 here? Let's use this test case. Run this. Sorry, print. Print sorted array. Five, 4, 7. How the hell did we get 4 here, bro? What? Maybe we can just get rid of all this. Okay. I hope. Guess we're using this test case now then. Ah, 445 minus 384, 61. We were expected 47. How does that work? I don't know. I don't know how this is meant to be 47 because I would have thought, unless we're missing something, turn the minimum absolute difference the absolute difference. Oh, it could be anywhere. Okay, so apparently we're gonna iterate through. So let's do like diff is equal to float. We want infinity by in range 1 to the length of sorted array. Want to check, well, maybe we would need diff is equal to min. We want our difference, and then we want our sorted array I minus sorted array I minus 1. And we return diff. Get rid of this. Okay. Maybe this won't submit either because we need the absolute value. Nope, it's submitted. Okay. Alright, I'll be back. Pause video, I gotta go to the bathroom, so I will see you guys in a second. Hey, what's up? We're back. We're gonna get going again. Let's take a look here. Take a look at another binary tree problem. I gotta get this all on I gotta do the in order. Oh my gosh, dude. I'm missing an email of myself. Excuses. I'ma drink a little more than I should tonight. Oh. I promise tonight. Excuses. I'ma drink a little more. What a good song, bro. 1605347. Okay, let's take a look at our next one. this email. Construct binary tree from pre-order traversal. Let's take a look at this one. Maximum width. Return the maximum width of the given tree. The width of the tree is the maximum width among all levels. Okay. So much texting. Sorry, guys. Okay. This is an interesting problem. The maximum width in the third level is 45309. What is this one here? Why wouldn't it be linked 7? Wouldn't it be... Excuses, wouldn't this be 8, bro? Like 1, 2, 4, 8. How many children at the 4th level of a tree? That's what I thought. So why is this 7, bro? Like, bro, how is this 7, dude? I don't understand how this is 7. Looks easy, but very tricky. This should be a hard. BFS, I knew that. Estimated time. See these images, you will get every idea. Null knows. Like, bro, I can do a simple, like, BFS approach, but, like... Let's just start. Let's just do from collections. Pull up the queue. And we can... Q is equal to DQ root. Promise denied. Q, we want to get the length. The length of Q, and for I in range length, we want to then pop, right? So q dot pop left node is equal to q dot pop left. Let me check. Sure. I just don't really understand this question fully, to be honest. The width of one level is defined as the length between the end nodes. The leftmost and rightmost non-null nodes, where the null nodes between the end nodes would be present in a complete binary tree. Extending down to that level are also counted in the length calculation. Wait, one. Oh, okay. Okay, so here in this case it would be 4. In this case we have 7 because we have the null nodes here. In this case, okay, it's 2. Damn, okay, that makes it a lot harder. I don't... Maybe we can count like... field append node. Sorry, if node dot left. I want to do if node dot right. Q dot append node dot right. I want to append the left here. Then we want to keep going because we want to append, well, okay, let's just return our how can we count these values though? That's the thing. This is an interesting way to solve it. Like, somehow we want to track indexes. So oh, those did I. Right. Then we need to need our max width is equal to 0. Last index first index equal to q. The last index is equal to -1 in the queue. Then we loop through, pop left if node the left. Therefore, node the left is going to have 2 children, right? So if node, well, every time we append a node, it's always going to have 2 children. So then we times our max width by 2, right, or something, or 2 times our index. Times our index, 2 times our index, right, for 2 children. Then we somehow need to update our max width. Get our max width, which is our max. We put in our first index, our last index. Oh, so we need to update our max width. So, whoops. Then we do our last index minus our first index, and then +1 to make it inclusive. And we return our max width. That's a great way to do it. I would have never thought about that, but that is definitely a cool solution. Can unpack non-iterable tree node object. Non-iterable tree node object. What is going on here? Promise tonight, God is due. I might drink a little more than I should. Oh, we need another parenthesis here to make it iterable. Whoops. Promise. Okay, EQ pen takes 2 arguments. 2 given. Node index, q dot append, node dot left, 2 times index, node dot right, 2 times index. Oh, again. We need to add double parentheses, bro. Hey, promise tonight, guys, to. I might drink a little more than I should. How about 1? Why is that? Our last index minus our first index plus 1. Turning our max width. Yes, we are. We're pending 2 times node. There we go. I just want to walk through a test case. I promise tonight. Interesting. Well, cool. I do understand what's going on here, but I don't fully 100% understand. I mean, we're taking Q0Q. All right. Let's check out some more problems. Construct a binary tree. I mean, these trim a binary tree. Diameter of a binary tree. How long have we been going for? About an hour. Maybe we should do something else. Let's go to like a hash table problem. We did intersection of arrays yesterday, intersection of arrays 2. Okay, well, let's just compare the difference between these two. Like, so an intersection of two arrays, we're given two arrays, we use a hash set, right? Yeah, I remember doing this yesterday. Return an array of their intersection, each element, and the result must be unique. Okay, here each element as well must appear as many times as it shows in both arrays. Okay, I understand now. 1, 2, 2, 1, nums 2, 2. So we got 2 here. We got 4, 9 here. So I think here, I mean, we did a set here, but I think probably the best way to do this is probably with a hash map. I'm thinking here we loop through each of these values. Yeah, I think so, yeah. So what I'm going to do here is let's create a dictionary, right? Create a counter. I'm going to do counter nums 1. Oh, well, I guess you don't know which one's going to be bigger. I guess you don't really know which one's going to be bigger, but it doesn't matter though, that's the thing. Maybe it doesn't matter. Because I'm thinking, I mean, bro, if we do a counter of this one, yeah, I don't think it really matters, to be honest. Like, so I mean, we're going to be looking for values in it, so I guess we can do my dictionary is equal to counter, and then we put in nums 1. I'm going to do, well, for I in nums 2, if I in my dictionary, then we create a res array, res is equal to this, and do res.append y, and then we would do my dictionary I minus c equal to 1. Let's return res, see what that gives us. I promise tonight. God, okay, so we got we got 9, 4. My dic I equal to 0. Then we just want to delete my dictionary. Maybe this might fix it. Okay. Nice. sort than 2 pointers. What if the given array is already sorted? How would you optimize your algorithm? Using 2 pointers approach to its best to keep the cost of sorting. If nums one size is small, compared to nums two sizes, which algorithm is better? The hash map choice. What if elements of nums 2 are stored on disk and the memory is limited such that you cannot load all elements into memory at once? How do they do the 2-pointer approach? They sort, leave the answer I, j is equal to 0, while I is less than nums 1 and j is less than nums 2. If nums I is less than nums 2, I plus 1. Also, if nums I is greater than nums 2. Okay. Trying to think about this, like what they're doing here. Like, if nums I is less than nums 2j, I plus equal to 1. Oh, okay. Well, if they're sorted, right? So if nums I is less than nums 2j, we increment I. If nums 1 I is less than nums 2j, then else if it's not, if it's equal, then we append. Okay, nice. Our promise tonight got us to the Tuesday. Print and sell after n days. And repeated numbers. We say these for another day. Powerful integers. There are 8 prison cells in a row, and each cell is either occupied or vacant. Each day, whether the cell is occupied or vacant changes according to the following rules. The cell has 2 adjacent neighbors that are both occupied or both vacant, then the cell becomes occupied. If a cell has 2 adjacent neighbors that are both occupied or both vacant, then the cell becomes occupied, otherwise it becomes vacant. If you're given an integer array cells where cells I is equal to 1, the ith cell is occupied and yeah, the description is a little confusing. I am a little confused, not gonna lie. Maybe we might take a look at a different problem. Let's take a look at a problem from Blind 75. Just something quick because, okay, with the greatest numbers advantage, we'll just do this and then we'll call it, I think. We have solved this one when September 9th, but when I kind of just started doing this stuff,
Let's take a look. There are n candies. Kids are given an integer array of candies where each candy's I represents the number of candidates the kid has. Denoting the number of extra candies you have. Return a Boolean array result of length n where result I is true if after the ith kid. Man, this problem description is confusing as well. So that's right, idiot. So. Okay. N candies, right? Oh, n candies are here, right? You are given an integer array of candies where each candy's I represents the number of candies the ith kid has. Okay, so each kid has 2, 3, 5, whatever. Okay. And an integer extra candies, denoting the number of extra candies that you have. Return a Boolean array result of length n, where result I is true if, after giving the ith kid all the extra candies, they will have the greatest number of candies among all the kids, or false otherwise. Okay. So 3 to 5 is true. Greatest among the kids. 6 true. 5 true. They got 8 now. 1 false. 3 6. Okay. Now what's the best way to approach this? What was the hint for each candy? Check if kids I plus extra candies is greater than max candies. Okay. We do for I in nums if. Sorry, we need to access name to see if I in range length nums. We check well if. Oh, shoot. This is candies. Candies. I guess we check well if candies I plus extra candies is greater than or equal to the max candies, then we return true, otherwise we return, return true. Wait, what are we returning? Oh, returning an array of booleans. Okay. We need to do, let's create our res array. And we do res.append. And true, else we append false. I hope that's kind of how you do it, and then otherwise we return res. Okay, cool. I feel like that problem was way too easy, but maybe we should take a look at something else. Can't place flowers. Let's do like, I don't know. Let's do like reverse. Reverse words in a string. We'll do this one, then we'll call it, because that was too easy. Like, I gotta do some other stuff too, so hopefully we can solve this pretty quick. Sky is blue. Given an input string as reversed the order of the words. A word is defined as a sequence of non-space characters. The words as I mean, I know we can just like return reversed. Yes, I bet you that was right. No. Return type is string. Maybe cast it into a string variable. Okay, alright, whatever. I know there's probably a one-liner this for sure, but okay. What's the quickest way to reverse this? I'm thinking probably creating a, let's call it a res array, right?
res equal to this, res is equal to list, we pass in our string, right? Then we create, well, we do loops, we do, let's call this like old res, and we create actual res, where we loop through for I in nums, I in length old res. And we start from -1, -1. Does this? I think this loops backwards. I think. Does this loop backwards? Guess we want to stop at 0. Go -1. And I guess we just want to do, well, res dot append old res I, and then I guess we just want to return cast res into a string. Type object res not iterable. Oh shit. I think that should work. Alright, index is out of range. Promise denied. God is scoops. Why is it out of range, bro? What the hell? Let's print old res. Get rid of this res dot append. This goes out of range, bro. What the? We start at all res, we stop at 0, we step by -1. Why am I getting this index out of range? Maybe it doesn't like this here, bro. I don't know. Let's get rid of this. Let's just make sure this is printing as a list. Okay. So it's doing it. Why? You're accessing all res I when I is equal to old. Oh. This is meant to be old res -1. That's why. Wait, length old res -1. What do we have before? We just had length old res. Right? Oh, there we go. Expected. I think this should work. Oh, damn.
Wait, what are we doing? What is the... I promise tonight. Got excuses. I'ma drink a little bit of shine. The sky is blue, but we're starting from here. But what between blue is sky there. Huh. Oh, okay. So we can't actually just reverse it. It's a two-pointer problem. Okay, well... When did I solve this? It's 2024. Well, if it's a two-pointer problem, think about it as a... Well, I is equal to 0. J is equal to the length of S minus 1. How do we want to do this? Well, I is less than or equal. I is less than J. Hmm. You can use the split method. Okay. Anyway. Okay, so maybe I and j is equal to both 0. Ij is equal to 0. And then we do for I. For I, range length S. I guess for j and range length S, we want to see, well, if j is equal to I guess we can make this a old res equal to list S. We can go through old res. If j is equal to this, then old res j. And we slice from
we get our word. Word is equal to all res I through to j. And we do like, we actually create a res array here. We do, well, res.append word. And then I is equal to j, and we have to move the I pointer up. And we keep going. I is equal to 0, j is equal to 0. Alright, and then we can, let's return our res, because I'm curious to see what. I promise tonight. Got excuses. I'm wondering with Russian tonight. Why is this not pinning to this? I think it's something to do with my slicing here. Not slicing properly. Oh, I need to look for that space. That's why, baby. The sky is blue. So now we've got a double list instead of a list. All res dot append. We can append this one, bro. The sky is blue. Blue is sky dot. Okay. Now we want to do create all res and append just so for lockdown, right? Then we got there. And we Python list is equal to item for sublist in nested list. Okay, then we can return the reversed item for Is this gonna return something? Oh my god, dude. Oh my god. How to flatten side of a list. How to flatten a list. iPhone. Corresponding function. Bro. From iterators import chain nested. Using list comprehension. Flat res equal to I for sublist in res for I in sublist. Return flat res. We can just add a space, word dot append no way this works, bro. I promised and bro, this is so much better way to do this than the way I'm doing it. And we can just return flatten the list. Then we can do, well, get rid of the last value. So flat res dot remove. Pop, remove last space, and then return reversed flat res. Oh, jeez, bro, what a solution, bro. Oh. Oh. For what? What? Return. Bro. Did I just waste all this time, bro? I didn't even do anything, bro. What did I do? Like, I just... The sky is blue. Blue is the sky. Bro, did I even do anything? Like... like, bro, what? Is less than the length of all the res. Bro, I started doing so much here that I forgot what I was doing. Like, I don't think I'm doing this correctly. I'm gonna get rid of it. Okay, let's just do. We have res, then we have. Well, what do we have here, bro? Come on. List string. We put into a list. We put it into a list, and then we print res, right? Then we go through here, get this word. I don't know, yeah. I don't want to waste 2 hours on this problem. I mean, I know I can eventually solve it, but it's like, bro, like, I don't have all day, like. Wow. I mean, bro, like. Let's not split, right? Let's print res. The sky is blue. Okay. For I in range length. Res -1 -1. So the 0. We do, well. left is equal to 0, right is equal to the length of res minus 1. And we do, well, left, right is equal to right, left. Do we need a while loop here instead? Yeah, while left is less than right. Left is less than right. Towards right. Towards right. Towards left. Then we increment. And then we decrement. And I guess we just return res. Oh my god, I'm just gonna change this to words, dude. I mean, like, I think the words minus 1. I'm kind of pissed I didn't get that problem that easily, but like, I think I had the right idea. I just like, I should have just used split and stuff like that, and I didn't, so. Words. Oh, excuses. I might drink a real bit, but I should. Bro. Need space. Here we go. Nice, dude. Alright, we're gonna call it there. Appreciate you guys watching. Thank you.